Apologize for the wait. We had a last minute critical issue come up, and it was to the point where Connor Cunningham actually joined the call. So if you don't know who Connor is, he works on the SQL Server product team with Microsoft. He's got access to the source code, basically. So anytime you can get his help, that's wonderful. Now, I just need to open up my slide deck here. So, and share my screen. So where is share? That's the one I want. All right, everyone can see my screen?
Yep.
Awesome. So we are here to talk about one of my favorite topics, corruption. Now, for many folks, myself included, when I first started learning about this, I really didn't know what to do. The first time I had to deal with corruption, it was about 3 a.m. Um, I had to learn a whole bunch of stuff on the fly, and you know what? I realized that's the absolute worst time to be learning about, something like this. The company I was working at the time didn't really have good incident management protocols either. They were still very much in their infancy. But as I you know learned more, gained more experience, I realized that there were a lot of things I could have done better from the first few times I hit corruption. And so the whole point of this session is not to, pull open a hex editor and be like, hey, watch me stitch together a database, right? It's to help folks understand how to protect themselves and properly manage corruption when it occurs. So I first gave this presentation, I think it was like 2016 at I'm not sure which sequel Saturday it was, but it was a lot of fun. Um, Gave it at Past Summit in 2008. Let me get this up here, and you are viewing. Uh, let's see. Let's turn off. Let's see. Let's turn off presenter view. All right. Okay, so apparently we'll go through it like this because it wants to send it to the other screen. So to give you a little information about myself, as mentioned, I am a data platform MVP. My previous company, I was vice president leading the database operations team. Now, if you know anything about financial companies, you know vice president doesn't mean the same thing most people associate it with. Vice president just means senior or low-level manager, basically. That particular environment was over 6 petabytes in size and created 200 new databases a week. So a pretty large SQL Server estate. As we increased, as you increase your number of systems, the likelihood of you running into corruption grows. Eventually, if you haven't experienced it already, you will. It's a matter of when, not if. So what I really want to do is I want to talk about what we are going to cover versus what we're not going to cover. I define corruption for the point of this presentation as the files themselves being physically corrupt. There's something wrong with the structure of your database. It is not, oh, we got some bad data in here, um, because we didn't take this into account in the app layer. It is something has gone wrong. Typically, a storage related issue has occurred. And as a result, your database is not in a good state. In fact, it may not even be accessible. So to that end, we're going to talk about tools available to us out of the box to monitor and analyze corruption as well as resolve it. We're not going to rely on third-party tools that claim to do X or Y. I would caution you in regards to third-party tools because I guarantee you Microsoft will not support your database after you use them. We're also going to talk about how to be very proactive about corruption, how to actually buy yourself time to test your backups and to, run integrity checks. And we will also go into how to respond to certain types of corruption. That'll be more demo focused when we get there. So, as I said, corruption, we're defining it as physical structure of the database, not being not being what it should be. It has become corrupt. This could manifest in several ways. Your database may be in suspect mode, or it may be completely inaccessible, or it may actually be functioning, but you can't access certain things. You get errors when you try, that sort of stuff. Now, corruption is going to happen. If you haven't experienced it already, you're very lucky. I have unfortunately experienced it more times than I can count. And each time people freak out. So hopefully this will help you learn to react more calmly and be proactive, giving them some assurance. Now, normally I would ask, the question of where can corruption be introduced? But the thing here is we're in a virtual world. It's not so easy. It doesn't make sense to stop. So I'm just going to tell you, SQL or database corruption can be introduced at any point in this diagram, whether it's in the database engine, the OS, local storage, or your switches, SAN controller, or the disk arrays themselves, right? Anywhere inside your system between SQL Server and the storage itself, it can go corrupt. And in fact, more often than not, the corruption is caused by storage related issues, which is why if you start to see storage related error messages in your error log, which I do hope you are reporting on, you may actually be headed for corruption. So this is important. So how do we approach this? Well, the first thing we need to talk about is the disaster recovery mindset. How do we respond mentally when, the worst possible thing happens? We don't want to be the people freaking out because other people are looking to us in these scenarios to guide them, right? I mean, how would you feel if the ambulance, the paramedic came by and took one look at the incident and and just started freaking out, you would not feel reassured. You would not feel like you're in good hands. So you do have to accept that disaster is going to strike at some point. You need to be confident that you are taking the proper steps to monitor for it and get alerted as soon as possible. And you need to have well practiced steps in play. You know, things you've tested before. A lot of companies do like a yearly DR test, but honestly, that's not enough, right? You want to know these things by the back of your hand. In this scenario, I'm going to follow these steps and I'm going to, you know, if this, then I do this, right? Because in the heat of the moment, it's easy to get distracted. So do build run books, and we'll talk about this stuff, incident response. And the final part of the mindset is actually to do what's called a postmortem, where you take lessons learned, what worked well, what didn't, where can you improve your process, and continuously evaluate them. This is true of more than just corruption incidents. This is incident management overall. All right. So when we talk about monitoring, um, we talk about three main tools that we have to help us with corruption. The first is SQL agent alerts. Then we also have this thing called CheckDB, and finally the suspect pages table in MSDB. Now, there are many different types of agent alerts. I'm actually going to provide a script that you guys can use to create these agent alerts on your system, so that you can send out notifications if they ever happen. And we're going to go through kind of what they mean. So the point of alerts in SQL Agent is to basically, it allows us to be notified of errors as they occur, right? We can say alert us whenever this severity type issue occurs, or whenever this specific error occurs. And this is useful for a multitude of things. For example, I actually have on my systems um, an alert for error 666 because I've run into it before and it's horrible. There's nothing like reindexing a 20 terabyte table, you know, the clustered index. Like, it's horrific. Um, so the other thing that we want to know is as we get up in severity levels, we need to pay more and more attention. SQL Server will actually tell you when it starts to think that your hardware is failing, right? You can get an early warning. Now, how early? I mean, it is already starting to fail if some of these things pop off. So, um, we definitely want to make sure that, we respond to these things in a timely fashion. But none of these things occur that I'm going to show you occur right out of the box. Just if you don't already have these set up, run the script, get them set up, assign them a notifier, right? I'll show you how to do that. I'll walk you through it. It's real simple and easy. So error severity level that you kind of want to pay attention to isn't necessarily corruption related, but it indicates you do have a problem with the system. And that is 17, statement ran into a resource limit. Maybe it ran into a limit that for memory or something like that, right? Maybe you need to look at adding memory, CPU, whatever. But there was a limit. Typically, these are tuning opportunities. If a query triggers this, I'm going to consider tuning that query. 18 is what's called a non-fatal issue in the database entry. That means the process didn't die, it didn't generate a dump, but it was an issue that it felt was, harder to recover from. 19 though is where we really start to get into stuff that should perk our ears up and make us investigate immediately. In the case of 19, there's something internal at Microsoft, some limit that was exceeded, and the SQL Server process terminated as a result. Now, it'll terminate and start right back up, but but this particular process was terminated. This is not good. You are probably going to have a dump file here. And when you open your support ticket with Microsoft, you can upload that dump file. They'll help you resolve and figure out what happened. I've seen things like this from an errant SP configure setting that shouldn't have ever been turned on. And I've seen it take down systems that were well provisioned with resources. So, absolutely you need to invest on that. All right. Well, let's skip down here a little bit to 21, because 21 might be a sign of failing hardware. Maybe it had to retry reading memory. In that case, you might have hardware failing. Something like that. Absolutely, from here on out, you investigate anything. 22 is SQL Server telling you you have corruption. Your heap or index is in fact damaged. Right? That is by definition, by our definition, corruption. 23 is even worse. That's SQL Server thinks that some of the system level objects, like the PFS structure or an IAM chain or something like that is damaged. And that can be scary because that can be, lots of lost data. 24, you almost definitely have failing hardware or it's about to fail. Be aware of that. Absolutely forward that to whomever needs it, whether it's storage or networking or whomever. Get that hardware replaced. 25 is much like 24, isn't necessarily corruption itself, but both of these things absolutely lead to corruption. Fatal hardware error is your hardware has failed. You are in trouble. Hit corruption. I once hit 24 and 25 because I hit a 30,000 hour limit in for an HP SSD drive that had a bug in the firmware version. After 30,000 hours, it bricked the drive. That, that created a whole ton of issues. We actually had to replace the drive, restored the database from backups. So not fun. So how do we create these alerts? Well, I have a nice handy VM up here. And if I go all the way up to the top here, I've made this real easy for you. All right. All we do is we run these stored procedures in MSDB, and it will create this stuff for us. I've also I've added another couple into this link, like error number 825. That's a read retry required. That means it had to retry a read operation against memory. So you might have a issue with your memory chip. in that scenario. But if you execute this, it will just create all of them as defaults. So you can fill in more detail here if you want. But as you can see, I've covered pretty much all of them down to 825. Right. So what'll happen is if I run this, let me start agent. Right, because this is a fairly fresh install of SQL Server for the purposes of this demo. So if I refresh that, we can see it's up now. You can see, got no alerts. So what we'll do to set this up is first we have to run this, and then we'll have to create notifiers, right? So I do that. I need to get rid of the job steps. I'll just create one for now. Oh, that's because. All right, I'll tweak it to remove all of those for you folks. And now, if I refresh this, you'll see that we have this alert, right? And we can configure the properties for this. So there is a response pane. So if we go to that, we can have it either. Oh, Dawn just took over. Hang on. I'm gonna share my screen again.
I don't know how that happened.
Eh, no worries, quick fix. Right.
All right.
So we can either set it up to execute a job for us, right? If you have some sort of automated response you want it to do, or we can notify some operators. Now, I don't have an operator here, but if I were to go here and select new operator, I could give it a name and I could put in email address, right? I could set their working hours, and then I could also assign them from here. And it would reach out to them and say, hey, this occurred. By the way, I would encourage you, anytime you are going to create any sort of alert here or anywhere else, third-party tool, whatever, put a link to troubleshooting steps for that specific alert in the alert itself. That way, when the alert goes off, people log in, they click on the link in there, and then boom, they've got a wiki page to help them out. All right, so we are through that now. Let me, fairly simple. Do we have any questions before I go on?
You
All
should be
right.
able to unmute yourself, folks, if you have a question. I don't see any in the chat right now.
All right. Let's go on to suspect pages. I promise this is going to get a lot more interesting in a moment once we get to CheckDB. This is where a lot of people screw up. There's another table in MSDB that's really interesting. It's called suspect pages. What it's used for is anytime SQL Server has suspicions that a page might be corrupt, it will insert an entry into this table. So if you monitor that table for new entries, you can get kind of an on-the-fly early warning report, much like alerts. So alerts tend to be real time. Suspect pages tends to be real time. CheckDB is however often you run it. So I like to have a monitor on here to watch this table. The key though is that you have to clean it out manually. So, you go in, you do your investigation, and then you truncate the table. And that way, you don't come back later and go, oh, there's something in there. One more thing about suspect pages, though. It does not mean that the page is definitely corrupt. It's just an indicator that there might be a problem with it. So we hear all the time that people are using or people should run integrity checks as often as possible. I like to see every day if possible. Um, some people only do it once a week. Some people almost never do it. So, do we have anyone here that is not running CheckDB at least once a week against their databases? I'm willing to bet that there's at least one. And there are reasons too. So, unmute yourself and speak up if that's the case. Because I'm happy to arm you with lots of ammo to bring back to your boss on why you should. All right. I guess everyone's running it at least once a week then. This is great. Usually there's at least one person that's not. But CheckDB is kind of our main tool for catching corruption. It should be run on all databases, including system databases. I know that it's hard to find time to run it at least once a week. The business likes to shove batch processing through on weekends. You barely have enough time for your backups and index and stat rebuilds. I get it. But this is one of those things, if you're not running it, you're gonna bite yourself on. I'm actually gonna show you a very elegant solution that many of you may be able to just run with for how you can do it. Um, Assuming you have software assurance or a lesser used system that you can dedicate to doing check your integrity checks elsewhere. Also has the benefit of testing your backups, which when we talk about corruption, we have to talk about backups. There is an option here that a lot of people when they go and they see this option, they go, "Oh, I'll run that," and that's the repair allowed data loss option. I've even heard people profess on the internet that, hey, run this against MSDB if it goes corrupt. And as I note here, I do not care what someone on the internet told you. You only should run this if Microsoft has gotten on the phone and told you to run it. There's a few things that happen. One, if you run this and Microsoft hasn't told you to run it, they are no longer supporting you. They will no longer support that database. So you have to copy all the data you can out of it into a new database in order to get them to support it. The other thing that happens is repair allowed data loss will determine for itself what it needs to get rid of. And it will just wipe out swaths of data. And you have no insight whatsoever into what data is gone. Now, you may be able to restore, log backups to 5 minutes before your incident and do a comparison. But why wouldn't you just restore the database from backup to begin with? You know, a lot of people run this when they first encounter corruption and they get themselves into a worse situation. So I went a couple of years ago, I went through about a 3-month period, maybe 4 months, where I got a lot of phone calls that went like this. And they were, the person would go, "Hi, so and so gave me your number. We don't have backups and our database is corrupt." And usually the reason they didn't have backups was because the corruption had entered the backups. It's another thing we're going to talk about. But, I'd ask them, "Well, what have you done so far? Where you're at?" And they'd tell me that they ran repair allowed data loss and Microsoft wouldn't return their phone calls. This happens. It's a bad place to be. In some cases, I'm able to walk them through how they can, you know, stitch their data back together from other sources, right? Not in every case. Every environment, every database is going to have things that are unique about it. And some of those can, really, really prevent you from recovering after you run repair allowed data loss. Um, if when I was last time I was doing acting as a manager, that was a no-go. That was instant cause for termination to run repair allowed data loss without without approval. All right, so let's actually look at our VM again here. So a couple things to show you. Let's find our CheckDB statement here. And I'm going to change my database context um, to our customer database here. And I am going to execute this. And I have actually introduced corruption into this database, right? And I want to show you something because I've introduced corruption in a very specific place. And sometimes CheckDB lies to you a little bit. When I run CheckDB, I like to run it with the following options. All error messages, right? So any error it encounters, it is going to bubble up, but no info messages, and format the results as a table. Because what this allows me to do is I can actually insert these results into a table. And that will allow me to um, keep a history of stuff. Or better yet, in most cases in cases where with these options where CheckDB doesn't encounter corruption, it doesn't return any results. So that means I can check for the existence of those results and alert off them if they exist. Right? Now I can page someone. We have found something. So in this case, CheckDB found something. And it's given us quite a bit of information here. So let's parse this. So this first line here, let me highlight it. It says there's an error in a table with this object ID and the index ID of 3. Well, an index ID of 3, greater than 1, we know has to be is a non-clustered index, right? So we know for a fact that this is a non-clustered index. So then the next piece of information right over here that it gives us is that this is an in-row data page. Those are the pages in the database on which your data is actually stored, right? So this contains actual values for the the index. And then it gives us the file ID of 1, because this database only has one file ID, or one file, and the page number, in this case, 465. And it gives us also a little information about what condition failed. Now, in this case, the way I corrupted this specific index was calculated. I basically overwrote a few bytes of the page. But you'll see that it's recommending a repair level of repair allowed data loss. Now, any query that uses that is going to fail. So, but we don't actually need to run repair allowed data loss. What we actually need to do in this scenario is simply alter the index and disable it, and then rebuild it. It's a non-clustered index. It is not the table itself. It will rebuild just fine. And all of these other related errors will go away. Of interesting note, there's also I overwrote part of the chain that links pages one to another in SQL Server as I did this. But we have a whole ton of useful information that we can pull from to find out exactly what happened. So we want to fix this. What we would need to do is, this is actually called IDX2, and we can get that simply because, right? We run this, we can get the name right here of our index. It's IDX2 name. I know, real original, right? So I'm going to tweak these here. And what we are going to do is we're first going to run the disable. Then we're going to rebuild. Then we're going to check for corruption again. Non-clustered indexes are a super easy fix. And you'll see CheckDB did not output anything there. So now you'll also notice that it put an entry for that there was an entry in that page in suspect pages. So CheckDB will do this as well as any queries that hit it. So what we would need to do to clear this out is simply to truncate the table. We know we've resolved that, so we're good. So now we also would have got there if we ran this, repair allow data loss, but then our database would no longer be in a supported state, and we wouldn't have known what data it got rid of. We would have been missing data in our index, right? So that would have been a potential problem for us. So let's go back and talk about backups. Well, not backups, but the restores. So how many people here test your restores? Feel free to unmute yourself and speak up. Anyone?
Yes, we have a weekly test restore process now, but that's
Okay.
fairly new. Yep.
Yeah, I think that you are the first person to stand up and say that you are doing that. Anytime I've ever given this presentation over the last, what, 5 years? So You are ahead of the curve.
Oh,
Um,
wow.
yeah, yeah, cutting edge. So let me ask another question. Is anyone here using sand snapshots as backups? The lack of response makes me happy. Um, how
We
many of
did for
you
many years, though, but I'm not sure we're still doing it. But we did it
yeah,
for many years.
Yeah, I know that
yeah,
the
it's
company I work for
the
uses those.
what about VM snapshots? Have any of you had your VM admins try to tell you, "Hey, we're just gonna snapshot the VM. You're all good."
Yeah,
That's a surefire way to having a corrupt backup because when they restore that snapshot of the VM, oftentimes your databases will come up in suspect mode. And that means, and usually because there's a discrepancy between the log and the data file. See, the log and the data file actually have this thing inside them that says, hey, here's the current log sequence number. And if those two don't match, you're dead in the water. So, that's a major problem. Um, I had an environment where that it was common that they would clone VMs to bring up new systems, and after every single time, okay, you clone the system, great, but you gotta restore, 30 databases now. Think products like Veeam, um, SAN backups, VM snapshots, even Commvault are not replacements for backups, for native SQL backups. This, one of the problems is they always look at the backup, but they don't pay much attention to the restore, right? And if the backup doesn't restore and you can't do that fast, it's no good. Other people think that clusters and availability groups mean you don't need backups. And that's not true either. It is possible for corruption to enter a primary in an AG and end up on your secondaries. I've seen it. I've dealt with it. It's painful. So, you know, it's imperative that we take actual backups, and even more so that we actually test them, right? Nothing's worse than coming and saying, hey, I need help. I have no backups, and the database is corrupt. Do not be in that situation because anyone who will help you is going to charge through the nose to help you, right? So, how do we test our backups? Well, what I usually do is I have a separate system. Usually, what I'll do is I'll have log shipping of my normal databases to what are called filers, and those filers will be SQL instances that will actually take full backups. Um, and then I'll ship those full backups off to a DR center, and I will actually have an automated process pick them up and restore those full backups so that I know the fulls are good. I already know the logs are good because, well, I just use them to restore, because log shipping is just backup and restore of logs. So with a copy step in between. Um, so if you do that, you take your backups and you ship them off somewhere else and have something watching that file system. So as soon as the new files are finished writing, it kicks off and it restores that database. Boom. You're going to immediately know that your backup is good, at least as of that moment, right? You can take this a step further. You could say, hey, now that the backup has restored successfully, let me run CheckDB against it. Now I've done an end-to-end network test for integrity. I verified that all the way to the DR site, there is no corruption. Now, if you can, I'd bookend that with running a CheckDB before you even take the backup in the first place. But it's more important to have that backup on the other end. Now, here's the cool thing. You know, depending upon your agreement with Microsoft, you may have the ability to set up a second system at no cost to perform these options. It used to be that you could only do the restores, but you couldn't do CheckDB. Now you can do both and still be within licensing. So for each of your systems, if you have software assurance, you should be able to go and actually spring up this other instance and do your restores and your integrity checks there without having to buy a separate license. That's kind of cool. So, but do remember, you're only testing it at that point in time. If something happens later on, the database in your DR center could still corrupt. Restore header only doesn't count. I really hope I don't have to say that. All that does is read, one specific part of the backup. It doesn't actually check it to make sure it's consistent. So please, please, please don't use that and assume you're good. So now we know how to kind of, protect ourselves from corruption a little bit, to how to monitor for it so that we get alerted as soon as possible before it has a chance to really get worse. So let's talk about incident management. The point of incident management is to have a repeatable process that allows us to resolve issues and identify ways to improve our environments. I've listed some key things here, like having an incident manager on call. But let's talk about, these in a little more depth. The rest of these a little more in depth. So what's our kind of role? Our role is to be prepared for this. It's to understand what to do when. Now, a gentleman named Steve Stedman has some pre-corrupted databases you can actually download and use to practice. Each one is a different type of corruption, a different puzzle for you to solve. And you will learn so much about SQL Server from going through this. I really highly recommend it. That being said, do it at home. Don't do it in your actual environment. Don't do it anywhere near a production server, please. I don't want your boss calling me and going, they broke a production by accident. So, what's the first thing we should do when we get alerted? Well, first thing is take a deep breath, right? Relax. Everyone counts on you. No pressure, I know, but relax. They want you to succeed as much as you want to get this put behind you. Trust me. These things do happen. Eventually, you'll become jaded enough that there'll be just another thing you deal with when it happens. But be calm, right? Your next step should be immediately to inform the business before you do anything else. This will mean calling whoever the incident manager on call is. Maybe that's your boss, and getting the stakeholders for that database or system into the right room. Inform other DBAs. Ideally, you get another DBA to help you out. That makes it a lot easier. One DBA handles communication while the other investigates the issue. That means you only have one person asking you questions as opposed to 15, right? Means more focus, and focus is what you want. So typically this will involve getting into a video conference, where you discuss the issue, you do some initial investigation and planning, but don't, under any circumstances, try to fix the issue immediately. This is going to hurt you. You want the owners of that database or that system to make those calls, right? They're the ones who have the ultimate authority over that database. Our job as DBAs is to inform and guide their decision making. That's why there needs to be proper discussion, proper understanding. If there's not, things could get worse, and you're going to be the one on the chopping block. And it's going to hurt you politically at that company for years to come. But if you get them to make the decisions, even if it's, you may have to tell them, you may have to say, hey, you own this system. I cannot do this unless you approve, right? That's perfectly okay. Once you've got everyone in the room, there's a few things you want to ask yourself. Is a restore faster than trying to fix? If that's the case, right, then detach, or back up the database, and so that you have a copy you can use to investigate later, if it'll let you. Don't detach and attach it. If it's boot page corruption, well, that's going to be horrific. You will have to use a hex editor to reattach that, unfortunately. But a restore is a perfectly good option. This is what we have backups for. Is that the only option, though? Is this database part of a availability group? For example, if it is, well, let's immediately fail over, right? Let's fail over somewhere else, take this database or this replica offline and repair what we need to repair. Meanwhile, the application is able to continue going. Yeah, you'll have to reseed it later, but at least you're minimizing the impact of the database, and maybe you can seed it at daylight hours. What errors and alerts do you have? Make sure everyone understands them and what they mean. There may be things in them that you don't necessarily understand that are more app specific, and you may need the app team to weigh in. Really, what you're trying to do is you're trying to put together a timeline of events, right? Now, I like to use this process called the 5 whys. Why did the database go corrupt? Well, because it lost access to its storage for a brief moment in the middle of a write. Why did it lose access to its storage for a brief moment? One of the, SAN controllers failed, and the other was already in a degraded state. Okay, we can keep going back, but the point is, usually by the time you've hit 5 of these questions, each going a level deeper, you have found your root cause, right? And based on that, then you can start to assess not just the situation, but how you got to the point you're at. This will go a long way to adding comfort. It's also important to make sure that you're working the issue as a group, right? You're going to be doing the bulk of the work, but it's a group decision. That way, people can't come back later and say, hey, you did X and it caused these problems, right? You'll be like, this was a group decision made to resolve in the best interest of resolving an incident, right? It protects you. It protects the other people there. And overall will lead you to better decisions, right? Again, we do not make decisions. We do not take actions. We may recommend a course of action, but that's it. No one wants that RGE, resume generating event. Now, usually when I've got another DBA there, what I'll do is one of us will start preparing the restore scripts to the latest backup that we know is good, while the other one does some research. The person on the restore script will typically also handle communication. But whatever your company's runbook is for incidents, make sure you know it and you follow that process. So let's talk about post-incident steps, right? So once we get out of the woods, the investigation is not over. You know, things are running again. You've gotten rid of the corruption, but we're not actually done yet. So, for example, we probably took a backup of the database before we restored it. So let's stick that over onto another system, see if it'll restore. If it does, great. We can continue to dig in. We can learn from this. Or, you know, maybe we determined that it was failing hardware and we need to follow up on that, right? We need to, you know, order new hardware, have a replacement, rush to the data center, get the sysadmins to install it. You know, or maybe we don't fully have root cause, but we've gotten the database to a point where it's usable, right? So the rest of that information investigation can occur when you get in the next day. What we want to avoid though is losing data. So anything that you worry you might lose, you want to gather that up, right? You absolutely, anytime you have corruption, you want to look at full stack hardware health. Your storage admins and your sysadmins will tell you, oh, there's nothing wrong. Make them check anyways. More often than not, they'll find something. And it'll likely be related to your issue. And even if it's not, they found an issue. They can fix it then, right? But everything you do needs to be documented, right? What are the action items that you are going to take? And then occasionally review those. So, you know, review them once or twice a year, you know, the incidents that have occurred, the generated postmortems, go over them and say, hey, were these things followed up on? If they're not, then make sure they're followed up on, right? So let's talk about another couple incidents here, right? So unfortunately, I do not have a due to my issue today with work, I was not, in fact, able to generate that suspect database. I literally putting a database into suspect mode. So I will walk you through the steps of what your options are, and unfortunately, they're not very good. I mean, there is an undocumented mode that can allow you to access a suspect database in some cases, and that is emergency mode. So if you run this, it'll set a database into emergency mode. You can then go in there and from there, check it out. But unfortunately, what you're effectively going to have to do is to repair the database, and you will lose anything that is in the log file that hasn't been hardened to the data files yet. So, that's something you do need to be aware of. Now, this is one of my favorites. TempDB corruption. So, can anyone guess does anyone know what happens with TempDB on startup of SQL Server? No. Okay.
It gets wiped out every time you restart SQL. I know that, but not sure that's what you mean. But
Yes, kind of. The contents get wiped out, but the files do not. So, when TempDB goes corrupt, right, you end up with corruption in there. What would you think is the easy button?
just delete it, or
Most people would say just restart the instance. The problem with that is
Right.
it will see that files exist for it, and it will reuse those files. It won't restore any of the objects that were in there, but I mean it will still use the corrupt physical files. So what you actually need to do is you actually need to go and physically delete the tempdb files off the disk. So you shut down SQL Server, you delete all the tempdb files, you start SQL Server, and it will recreate them from scratch. There's a problem with that though. If you're like me and you've got some databases with very large tempdb, it's going to have to create large files. So you might see a much longer than normal startup. So we did this once on a database where tempdb was, I think it was 400 gigs. And it took close to an hour for SQL Server to actually fully boot because it was recreating those files. So just be aware there is a downside on that. TempDB corruption the fix is easy, but you may have an issue. You may have to wait a little bit. Now, unfortunately, if we showed a non-clustered index earlier, but if your clustered index is corrupt, that's a huge problem, right? That is the actual table. Or the heap is corrupt, right? That is also the actual table. So that is a major problem. In that case, you're looking at either rebuilding that data from some other system, from a backup, or just restoring a backup. Not a good place to be. And to be honest, typically when corruption strikes, it's going to be a mix because the odds of corruption just hitting one specific object, oftentimes it'll strike in multiple places, and you'll have to do a little bit of firefighting. So be aware of that. There's I briefly mentioned this. Is anyone here familiar with the boot page in SQL Server? All right. So let me do this. What is that? Is that DB info? Ah, yes. Sorry, I had to turn a trace on. Three, 6, 0. There we go. What you are looking at here is probably the most important page in your database. This is the boot page. It is always page ID 9 of the first file in the primary file group. So this is where you will find things like, the last time that CheckDB ran, right? This was the last time CheckDB came back good. If this is sometime in Victorian era, turn of the 19th century, that means CheckDB has never been run, right? Now, this also takes with table results. So you can put this into an easier to read format, right? But it gives you a whole bunch of good information. This is also where where I believe the, actual LSN, the log sequence number, is recorded. If this page is corrupt, your database is you're not going to be able to start up your database, period. You are toast. Your recommended option is to restore from backup. Barring that not being an option, well, then you are pulling out a hex editor, and you're going to have to go through a process that Paul Randall describes on his blog called hack attaching. The synopsis of that is you create an identical database in terms of structure, same file groups, same partition, or same number of files per, that sort of thing. And then you copy the boot page out of that into this. And then try to attach it with SQL Server. It's a very messy process. I guarantee you Microsoft will not support you after you do that. At least not for that database. But this is the single most critical page in your database. It will not start up without this. So your best bet in that, or your only realistic solution, is to restore. All right. I apologize for not having more demos built for you. This is a new computer, so I haven't had a chance to migrate everything to my VM here. But I hope this is useful. Does anyone have any questions or want more stories from the trench or what?
Yeah, when you run that CheckDB, like how long does that typically take? Is it based on database size, or how much of a window do you need to leave for that? You
So
have a pretty
it'll
tight window
depend.
already.
It'll depend on a few things. One of the biggest is size of data, but also it'll depend on the version of SQL Server. Anything past 2016 they put a lot of optimization into CheckDB. In fact, they fixed the bug. It used to be that you could tweak CheckDB by using resource governor, and limiting it somewhat would actually make it faster. You no longer need to do that. But it will also depend on the resources and, CPU, memory, the speed, the latency of your disk. All of these will factor in. I can back up a 3 terabyte database in about 20 minutes. I can run CheckDB in about 30 minutes on that same database. So if you're looking for ways to optimize CheckDB, like you can't afford to do it all at once. CheckDB is actually a set of commands. It's actually running a set of commands underneath the hood. What you're telling it is pretty much run everything. But you could just do, certain operations each night of the week and just do a little bit at a time. That would make it faster or less impactful. But your best bet is to simply have a separate system, copy the backup over there, restore it, and then run CheckDB.
Great, thanks.
Any other questions? All right, well, if there are no other questions, let me just reinforce. Restores are everything. Absolutely everything. If you don't have them, you're in trouble. You're not prepared. Understand your environment and options. That includes, right? That includes your processes. What are the proper protocols? Don't be rash. Let the stakeholders drive. And do practice. In fact, if I were to go, ooh, I'm gonna pull up a browser here. Alright. If I were to go here and say Steve Stedman, database corruption challenge. I'll show you how you can download these. All right, you can see right on this page that's easy to find. He's got a list of who won these contests. So you go into one. I won't click see solution, but so corruption challenge 1. Here we go. Here's the actual post. Right. So all of this, he's got a zip you can download. You'll get the file, and everything will go from there. He's got a little worksheet for you. All right. I absolutely love what he did, by the way, in case you can't guess. All right. These are things I encourage you to download this sheet and work off of it if you have a corruption incident. I have similar that I work off of, but you can browse through each of these. You can look for the solution. For example, we will look at the solution for the first one. You will find the details here. So, but notice everyone's doing this in VM, so please do so. All right. All right. That is all I have. Anyone else have any questions?
Brandon, you mentioned a restore process that you use to run your restores as soon as your backup's complete. Is that a PowerShell script or something you can share with us? Or
So it varies a little bit with every company. I can tell you the process is simple. Um, you know, have DBA tools manage the process, either executing Ola Hallengren's jobs, monitor the job history tables to see when they complete, and when they complete and the file is there, PowerShell to copy it over, or even, you know what, make it even simpler. Agent job. You've got your first step is your backup. Your second step is your copy, right? And then you have another job on another system that just watches a folder. And as soon as a file is copied over, it grabs it, looks at the file name to understand what the database name is, and restores that.
yeah, okay.
It's really simple. In fact, you could probably even base it off of what log shipping does, right? Just go and look at log shipping jobs. I mean, you'll be able to reuse some of that code there to do it.
All right. Well, currently, we have a job set up on the weekends that we run through, and it looks at the backup. It's the DBA tools
Yep.
scripts, and it goes and finds the most recent full backup. We don't do the logs when we're doing our testing. We just do the fulls,
Yeah.
and it is nice. It's fully automated. Brings it up, deletes it, does the whole shebang for you.
Yep. Yeah, DBA tools has made DBA's lives a lot easier. Back in the day, I was doing stuff like that, but I'd have to write it in C# in .NET, creating programs called DBA.exe and stuff like that. Not very intuitive, so to speak. Um, most of that stuff I've thrown out now, and DBA tools is my friend. All right. Any other questions?
I'm guessing not. Speak up if you do. Just want to say thank you, Brandon, for taking the time to be with us tonight and running through that rather quickly at that. I'm sure you
Yeah,
prefer to have more time, but you did well
I
to
would.
compress it.
I would, but we are getting late for people here, and I was the one who was late, and for that I am sorry.
That's our job sometimes. So, but greatly appreciate it. Thank you all for coming tonight, and I will I'll stop this recording, and I will get this recording posted.